Beginning Bioinformatics, Part 4. Today we're going to jump into learning Python. So the first thing you'll need to do, as usual, is go and download the Word document from Canvas that goes along with this lecture. It is Part 4. So this first bit is just a little bit of an introduction to Python, some of the nice things about it, but also some of the challenges. So when I start talking about dependencies here, I'm not going to walk through this, but you should read it. It's here for a reason, valuable information, and then a little background about package managers and what they're good for, why we use them. And then the last one here, Conda, is really the back end, or what kind of goes on in the background. The Conda package manager is what's behind this software called Anaconda that we're going to install first. Okay, so P1 is to install Anaconda, and this was all the way back in the introductory video. I mentioned this. I showed the link. It's also in the Getting Started module technical requirements page. Same link. So you'll want to follow that link. Should open a browser here to get the Anaconda distribution, and it should automatically recognize the system you're on. For me, it's a Mac, and I would just download and install that like any other software. Okay. Once that's installed, you should find an icon that looks like this. It's an anaconda, a snake circling back on itself. And so you'll want to launch that. Once the program launches, you should get something that looks like this. Now your tiles might not be the same as mine, even between this screenshot and a most recent update. Some of the tiles have changed, but as long as you have JupyterLab as a tile and Spyder as a tile, you'll be fine. So that's the home screen. The next thing, and this gets back to the package manager aspect, this is really a graphical interface for a package manager. It also has those nice features of having the app integration. So those development environments that we'll get to in a second for P2 of the tutorial are the applications. But this is, if you click on Environments tab, you'll see I've got 3 environments. You may have only the base environment. But then on the right-hand side are a list of packages that are installed along with their version. So the Conda package manager is maintaining a list of the things that are installed on my system already. It also has a catalog of repositories, so I can look for things that are like updatable. So the things that are not installed, if there's something that I know I want to go look for, I just type to bio. So there are some packages that I don't have installed. I could click on those and it would go to the repository, grab those and install them on my system. We'll do some of that later in the semester. Okay. So that's the package manager side of Anaconda. Right now, we're going to get straight into the development environments. So like I said, JupyterLab and Spyder are the main 2 that we'll use. These are the 2 that I use in the tutorials. I'm mainly going to use Spyder, but that's just because I think it's a little bit clearer for the videos. The programs, the code is more condensed. Might be, I think, easier to follow. But in my day-to-day work, I often use JupyterLab. So I'm going to show you JupyterLab here in a second, and then I'll switch back to Spyder. And that's what we'll mostly use until we get to plotting and until we get to working with data frames, which you can think of those as Excel files or big tabular data. Those are also easy to visualize in JupyterLab, and so we will switch over for that. But ultimately, which IDE you use is a matter of personal preference. I don't know any technical reasons why you might pick one over the other, except for you know, each has their strengths and weaknesses, and I list a couple of them here. I'll let you read that on your own, but just know that the tutorials will mostly be done in Spyder, even though a lot of times day-to-day work I'm using JupyterLab, and I can see where, as you're learning to code, the immediate interactivity of JupyterLab that you'll see in a second, you know, that may be useful for learning to code. So the first one here, let's take a look at Spyder. So go back to the Anaconda homepage. Here I've got my Spyder tab, and I just click launch. And it's launching on my other screen, so I can see the splash screen, and there it popped up. Okay. And it's telling me there's an update available because it checks for updates every time it starts. I'm not going to do that right now. And this is the basic Spyder window. So clicking back over to the document, you can see you've got the different areas, my text editor, my console, which is where things actually, you'll see the input output when I run code. So this play button will run the current file, which is in the text editor. If I want to run single lines, I can do that in Spyder by clicking that button with the sort of cursor icon over it. There's preferences and then file nav options, because I talk about one of the nice things in Spyder is that this text editor, it doesn't only deal with Python code. You can open a regular text file there. And especially if you're on a Windows machine where line endings might be a problem, which I talked about back in one of the Unix sections, you can see immediately what the line endings are in a file by that little the abbreviation right here. This LF is telling me that whatever's in this coding window or this text editor window has the Unix line endings right now. So it's a quick check. I also give you instructions here. There's a way for you to have Spyder automatically check that and give you a warning if they're not correct, and convert them to Unix line endings anytime you save the files in Linux. So I've given you some instructions to do that here, although I won't walk through it. You can do that on your own. Because whether it's set up or not isn't going to impact what we do for the rest of today, and hopefully it never becomes an issue for you, but it's just so that you know it's there. Okay, so I'm going to come back to Spyder in a minute when we start using it for some of the rest of the tutorial, but for now, let's jump to JupyterLab. So we'll go back here. JupyterLab, click launch. And it should open a browser window for you. So JupyterLab runs in whatever your default browser is on your machine. And I'm going to close this. I'm not sure if it opens a blank page or it opens the launcher for you, but if it opened the launcher, just click Python 3, because we're going to do a little simple Python code here. If you want to run the current cell, so this is a cell, there's a play button here as well. Okay, and the little task that I set up here is just to do import this, which is going to print this poem by Tim Peters about the Zen of Python. So running code in JupyterLab is super easy. You just type your command into the cell, And you can either hit play, or I'm going to do shift return or shift enter. That's the shortcut, the keyboard shortcut to run a cell is shift enter. And then it runs your code. Okay, and then by default, it opens up a cell so that you can do another command. Okay, so this might be a useful IDE for you to learn to code in, because you get sort of that immediate feedback. You just type in a code, hit shift enter, and it's right there for you. But you can also see why in a video, if I was doing that, I would have pages of command output, and I think that's not, it isn't easy to see the flow of the code when I start to build up multiple lines of code to accomplish a given task. So that's why in the tutorials I'm going to use Spyder most of the time. But if you like Jupyter, I can totally understand that. Like I said, I use it all the time myself. You know, feel free. There's no reason not to. Okay. And just in case it's not totally obvious, this part over here on the left, why I like JupyterLab, one of the reasons I like JupyterLab more than the straight Jupyter notebooks, which if I switch back over to Anaconda, there's this Jupyter notebook, which is sort of built on the same framework. JupyterLab just has some extra features that I like. One of them being, I like the file management system in JupyterLab a little better. Okay, so this will let you, you can navigate your file system right here in the left panel on JupyterLab. Okay, so that's all I'm going to show you about JupyterLab today. Feel free to use it if you want to. For now, I'm going to switch back over to Spyder. And Spyder's three main windows, right? Our text editor. Here, this is the file browser window, although it has multiple uses. So it has a help, these little tabs on the bottom. This will show me which variables are active. If I do plotting functions, the plots will show up in that window. What I usually have it open to is the file browser. So this, again, it just helps me navigate the files that are on my computer. Okay, and then it also shows me the path to those files. So current working directory for Spyder is users, and then my username, and then the bin directory. So I'm just going to live in this directory because I can save them here. And when we talked about all that stuff about the path in a previous tutorial, I'll know that my bin directory is set up in my path. And so if I want to go execute something from the terminal, it should work easily if it's in that bin directory. Okay, the Spyder never has an empty text editor window. By default, it opens this temp.py file. If you close that, it automatically reopens another file. That's just one of the default behaviors for Spyder. So if you see something different than what I have there, which you definitely will, at least in terms of who the author is, this text is not actually code. This is all comment lines, except for the first line, and we'll talk about that special line here in a second. Okay, so back to the tutorial. First program we're going to write in Python is hello world, much like we did for Unix, except here, right, in Unix, remember, to get something to print back to the screen, we use the command echo. In Python, the command is print. So let's create our first Python program. So I'm going to go over here, and I'm not going to modify any of this text. It doesn't look exactly like what I have here, and that's just because the Spyder version has updated, and I haven't remodified the default template. And to be honest, it's just not worth doing at this point. This first line, so let's talk about that. The first line is called a shebang. Okay. And it's similar to what we saw in the Unix tutorial, but in this case, it's telling the shell. So if we were running this in a terminal, it would be telling the bash or the Z shell interpreter to use the Python interpreter to run whatever follows that shebang. Okay, so really what this is telling bash or Z shell, the terminal, read the rest of this using the program that I'm specifying here. So here I'm giving it a path to Python 3. Now what you'll notice if you see something like this, so this shebang, let's see if I can blow this text up a little bit, is a little bit different, but it should still work on your system. The install for Spyder is typically smart like that. It's going to give you an appropriate shebang by default. Okay. I'll talk about if we run into problems in a second with the shebang issues and how those show up. But for now, we'll just leave it. And so all I'm doing now is adding this print hello world command. All right, so I'm going to get rid of that shebang. And now my line numbers don't add up or don't line up with what's in this, but they line up with what's here. So that's the shebang. Line 2 is my print function, and then anything inside quotation marks is just going to be read as text to be printed literally. Okay, so even if I had numbers or other characters in there, it's going to be printed. Anything inside the quotes is just printed the way it looks. Okay, so then we'll save this in our bin directory as hello.py. So here I'll click the save button. Hello, and it gave me the .py by default. It's in bin, save. I already have one there with that name. I'll just replace it. Okay. And then to run this in my Spyder console, so to run it inside Spyder, I just hit the play button. And hopefully you can see there's no way for me to increase the size of this. At least there wasn't. Yeah, so I can't zoom in on this text for the console, but hopefully it's big enough that you can see it executed that file and returned hello world exclamation point. So exactly what was between the quotes there. Okay. So hopefully you see something like that. Now, that's running it inside Spyder. What if we wanted to run this from the terminal? So let's open a terminal window. And I've changed the color on my terminal just for fun since I did the screenshots. Okay, so I open a terminal. I'm in my home directory by default. I need to cd over to my bin directory. So now my prompt says I'm in my bin directory. And I'm going to do ll just to look at what's in here. So there's my hello.py. And now I'm just going to type hello.py. Okay, and it worked. Okay, so if it worked, woohoo! We just created our first Python program, and at least for this course, and been able to run it. Now, probably you got an error because this has executable permission. So the most common error that you're going to get here is permission denied. Okay, because you haven't done chmod +x to give executable permission. If you got an error, permission denied or command not found, right? If it's command not found, that means that wherever you saved hello.py is not in your path. Okay. You have to go back to U45 to U42 to 45 from the previous tutorial to go back and figure out how to fix permission denied and command not found errors. In this case, one of the things you can check, especially if you got the command not found, is if it's because Python 3 wasn't found, you can try executing it like this, type Python 3 hello.py, and that will force it to use Python 3 to read this program, right? So that's seeing if maybe the shebang was the problem, rather than just simply the path to hello.py not being recognized. Okay. Now, if you got a bad interpreter or an interpreter not found error when you tried to run it, that's definitely a sign that the shebang is not correct. Okay, so it means it can't find Python 3. This should fix that. So if you do Python 3 hello.py, and you run it this way and it works, the bad interpreter error goes away. That means it's a shebang problem and you might need to change your shebang. How do you know where Python is located? Well, you can type where Python 3. I'm going to zoom in here a little bit because that's probably kind of small. Sorry about that. Where Python 3, and it will tell you, in this case, I actually have 2 Python 3 versions installed. One installed by Anaconda and one is the default that's installed with Mac. Doesn't really matter. This is I just use the shorter one all the time when I'm having to put a shebang in manually. Hopefully you don't have to deal with any of that, but if you get those bad interpreter problems, that will be one way around it. So what you would do then is whatever yours says is the path to Python 3, you need to go back and put that in your shebang. Now you can see it works for me. Right, you can see that was my shebang, and then the new shebangs that in the new version of Spyder, this user bin environment, this is just a fancy way that they've tried to fix all of these bad interpreter problems, because when Anaconda installs Python 3, it puts an environmental variable in to specify the path. It's okay if that went right by. You don't have to understand how that works at this point. Hopefully it's not a problem. Okay, so that's hello.py. Hopefully you have now written your first program. You're able to run it in Spyder. You're able to run it from the terminal. If you're ever having problems with Python, or in some cases, if you just want to execute see if a command will work in a very quick and dirty way, you can start a Python 3 interpreter. This is also a way to find out what Python version you're running. So I just typed Python 3 at the command prompt, and now I'm actually running an interactive version of Python. So I could do, for example, import this, and it printed the Zen of Python for me. Okay, I could do the print hello world. And it ran. So this is just interactive Python. If I want to get out of this and go back to the command prompt, the bash or Z shell command prompt, exit, open, close parentheses, and I'm back to my regular command prompt. Okay. If you ever want to get rid of your text, right, I just want to clear my terminal. Boom. Okay. The next one, P5. I'm not going to go over this, but this is something I feel like you should know as you go on in bioinformatics or data science. Python 3 went through a major revision from version 2 to version 3, and many commands were fundamentally changed in a way that is not backward compatible. So I'll let you read through some of the sort of trivial and not so trivial reasons that's important. It's something for you to be aware of as time goes by. This is several years since Python 3 has been out now, and so the issues become less and less important. But especially if you're using a package that was written 5 or more years ago, there's a good chance it was written in Python 2, and if it hasn't been updated, it may not work correctly, and it may be wrong in ways that are not recognizable, not immediately apparent. Like it doesn't throw an error or a warning. It's just wrong. Okay. And that's especially if you're incorporating modules that are old. Okay, so just be aware, read through that. Something to hopefully just log in the back of your mind. And as I said, as time goes by, it's less and less an issue. Almost probably everything we do this semester will be strictly Python 3. So that all hopefully never becomes an issue for you. All right, let's get into some more sort of meaningful coding. One of the first questions that comes up after you want to know how to get the computer to print something in a language, in Python in this case, is how do I assign a value to something? So that is the assignment operator. In Python, it's a single equal sign, so very simple. It's just the name of the variable equals some value. You're assigning whatever is on the right to the thing on the left. First round here, let's just make it super simple. We're going to assign the value 18 to the variable name x. So let's go over to Spyder. I'm going to close hello.py and it says create a blank text, and we'll save it as variables.py. Okay, so it's not blank. Again, Spyder fills in that stuff by default, but let's name this variables. And again, I'm going to replace what I had before. And so again, because of the new way that it's filling in the shebang and the extra text, the lines don't match up. But if you look at this version in the document, I've left 2 and 5 deliberately blank, but you don't have to leave them blank. Python is very forgiving about white space, meaning extra carriage returns and extra spaces. Okay, so as you're learning, I know one of the frustrating things can be not knowing whether the spaces are meaningful. So here, x equals 18, I have x space equals space 18. Those spaces can be there or not. You can have multiple spaces. Python doesn't really care most of the time. And so I am putting like these blank lines in and the spaces there just to make it more readable. One of the great things about Python is that it is a very readable coding language. Usually you can get an idea, even if in this learning stage, what the code is supposed to be doing, because it's just intuitive. Right here, we're making x equal to 18 and then printing x. Lines 3 and 6 here, when you start a line with this hashtag, it is just a comment line. That means it's not going to be executed. It's just there to explain what the code is doing. That is very useful if you're ever going to give the code to somebody else. So, for example, if you're a grad student working in a lab and you want another grad student that's going to come after you to be able to use your code, super useful if it has comments that say what the code does. Okay. So that's all those lines are doing. The exception here is the shebang line, right? That hashtag exclamation point says this is a shebang. This is where the interpreter belongs, or where it not belongs, where it is, where to go look for it. Okay, so 4 is our variable assignment. Line 7 prints it. Okay. Let's go back over here. We've got that code. I'm going to run it in Spyder. So here, input to run file, and it ran and it executed, and this line gave me the value 18. Okay, so all good. Just a couple comments here. Best practices in Python coding. Variable names get all lowercase letters. And even though right now I'm using very simple variable names, when programs get more sophisticated, you'll want to make your variable names meaningful, right? It helps, again, with that readability. If the variable name actually tells you what the variable is meant to hold, okay? Right? X doesn't tell you anything about what 18 is. What is 18? What is that number for? Whereas, you know, if I named it something like best hit, then that is the value of the best hit. It would have some meaning. And as we get more and more variables in the code, naming them something meaningful is helpful. Now, if you have a multi-word variable name to make it meaningful, you can't put spaces in the variable names, so you use underscore. Okay, so this is, you can't really read it because of the way Word is highlighting that as a misspelling, but it says best underscore hit. Okay. So P7, let's learn about data types. The operators that we're going to learn about, so in P8, we're going to look at how to manipulate variables, or, you know, add, subtract, multiply them, and so on, or how to compare them. Those work differently depending on what type of variable they're being given, right? Adding integers is not the same as giving the plus sign to add integers won't be the same as giving the plus sign to put two strings together. So the main ones that we're going to use throughout the semester: integers, float, that's just a number with a decimal point, a string, which can be any kind of text, and a list. And lists can contain any of these other more simple types of variable. And then the final one, dictionary. This is like a list, except the things that index where it is in the dictionary can be strings or numbers. Okay, we'll get into a lot of detail about lists and dictionaries because they're very useful data structures as we move along. So Python is typically very smart about automatically assigning the right type of data, the right type of data type. So when I say X is 5, X gets recognized as an integer type variable. In contrast, if we say X equals, and then we put the 5 in quotation marks, that will force Python to automatically make X into a string type variable. If we said X equals 5.0, Python is going to automatically assign it to a float type variable. So let's look at this here in our variables.py program. Let's add a couple more lines here. Go back over to Spyder. Let's make that big for you again. And add these lines. Now, obviously, I'm copy pasting these from previously written stuff. So pause as we go through this as much as you need to. So I've just added the same lines that we have here in the tutorial. in my variables program, and let's run it. Okay, so what happened? Well, it's printed this line, which is still 18. And then I assigned it those variables, and then we have another print line here that instead of printing the value of X, I told it to do type, right? So this is the command type, and then the parentheses, inside those parentheses goes whatever variable you're asking it to give you the type of. So X is 18, it recognizes that as an integer. Z is 5.0, it recognizes that as a float. A has hello in quotes, and it recognizes that as a string. Okay. Now, something that I didn't talk about in the text of the task is this last bit. Sep equals \n. And I should also mention here, this has single quotes. Didn't actually mean to do this, but single and double quotes work the same 99% of the time and in fact, I can't think of any situations where it matters whether you use single or double quotes in Python. So these double quotes act the same way as single quotes. In this case, it's saying separate each of these outputs with a new line. Okay, so that \n is just like we saw in Unix with new line characters. And that's why it printed each of those outputs. Well, not this one, because this was a separate print statement where we got 18. That was this print statement up here. But then this is one line, and it separated them with a new line. So if I delete that bit, just to show you what happens, right? Now it printed them all on the same line. So everything in that print statement was on the same line unless I use the sep to put them on different lines. Okay. So just a little bonus content there. All right, let's operate on these variables. So here, this is just one place for you to go to see some of the most common ones. So they're all, you can always go back to P8 and find your operators if you forget how to specify them. The arithmetic operators, obviously 2 + 3 returning 5 assumes that you're adding integers. Like I said, if you have text that you're gonna, or strings that you're adding, plus is not gonna work the same way. We'll see that when we get down to this code. The comparison operators are actually a test whether something is equal to or not equal to something else. The output of the comparison operator is always true or false, right? If like 5 = 2, this would evaluate to false because 5 is not equal to 2. Okay. So just a note about that. Just keeping those straight, especially when you're learning that double equal is testing whether it's equal to something. A single equal is forcing it to be something, right? X = 5 is forcing X to be equal to 5. And if you did X = 5, that would evaluate to false because X is not equal to 5 unless you made X into a variable and specified it to be the value 5. Okay, I'll give you a couple other examples there. We will use this a lot. Okay. So we're going to add these lines Come back to our code here. And you go ahead and add those lines to your code. And then it says, let's save as. File, save as. So I have to use the file menu to do save as on Mac. But we'll save this as equations.py. Okay. And so now I've added this text. So what this is going to do, right? Everything in quotes is just text, and then it's actually doing x plus y. So in this case, x is 18, y is 5. So really this should say, when we run it, it should print literally x plus y equal, and then the sum of 18 plus 5. So that should be 23. Okay. So let's run it and then we'll walk through the rest of those. All right. So now we have 3 print statements. Printed 18, then it printed our variable types, integer, float, string. Now this is the new stuff. So the first line, just like I said, x plus y equals 23. The second one just says false. So what happened? X plus y is 23. And then equal is the comparison operator saying, does that thing on the left equal this thing on the right? Well, no, 23 does not equal 20. So we got false. The next line, right, printed the text and then did the function. So x divided by y is 3.6. And then it did x to the power of y, so x to the 5th, so 18 to the 5th. Then, now we get the interesting bit. And just so it's clear, right, that x to the power of y, that's that evaluation. And you can go back here. This is why I put all of these in one place. If you want to know the power exponentiation operator, it's double asterisk. Okay, the division operator. Okay, that one's pretty clear, but I didn't talk about the modulo operator. This is if you ever want to get just the remainder of a division operation, you can use this percent symbol, which is called the modulo operator. So for example, 18 modulo 5 does 18 divided by 5, but it returns 3 because that's the remainder when you divide 18 by 5. So getting back to our command here, A plus B plus C. A, B, and C are all text. So these are all string type variables. So what does the operator plus do when it sees a string type variable? Well, you can see how it printed with no spaces. And compare that to when I do A comma B comma C. The commas give you spaces. The pluses, they concatenate with no space. Okay, and then this multiplication operator, when it's acting on a string, it just does it that many times. So this is C is the exclamation point times 3, printed the exclamation point 3 times. So the task here is to try to modify that so that the last output is exactly hello space world with 3 exclamation points. Okay, so pause it here, try to solve that yourself. I'm going to comment some of these these other extra print statements out. So if you ever want to avoid printing extra stuff when you're trying to troubleshoot code, just comment the line, and now that's not going to happen. When Python reads this, it's not going to see those print statements as something it needs to do. And I don't need that one. I don't need any of these anymore. But how can we make it print hello world with 3 exclamation points? Well, if I wanted to make exactly like that, I need to change that to a capital and that to a capital. Okay. I'm not going to bother to write code to change the capitalization. I could do that, but it's just not worth it. Unless we had to do it in a whole file of things. Just because it's 2 hard-coded variables, I'll just change the text there. I want a, and then I need a space. So how do we get a space? That's a comma, then world, which is B, but then I don't want any spaces before my exclamation points. So I want to concatenate C, and I want to print C 3 times. All right, so if I run that, okay, notice I commented out all those other previous print statements. So it ran this code, it skipped over all of those commented print statements. And in fact, yes, I got hello world just like I wanted. All right. Last 2 things on this section 8 is if we want to store the results of a computation as a new variable. So here, come back here, comment that line. Don't need to print that again. Now the variable named Z is going to get x plus y divided by 2. So if we go back up here, Z has the value 5.0. I'm going to put 2 print statements just to show you, just as a warning, what happens if you aren't clear about your variables, what can happen. Okay, so let's run this. What do you think's going to happen? It's always nice to ask yourself, what do you think the computer is going to see here? I'll tell you what it should see, I think, is it's going to print Z, which is 5.0, and then this line is going to overwrite that. It's going to do this computation, which will be 18 plus 5, 23 divided by 2. So Z should get overwritten with 11.5. And then this print will be 11.5. So it should print 5.0 and then 11.5. Let's see. I think like a computer. Yes, in fact, that's what it printed. Okay. So, right, just fair warning, right? This goes back to naming your variables meaningful things and keeping them straight. Just because Z had the value 5.0, I can then assign something to it later and it just overwrites. It didn't give me any warnings. It just got the new variable. Okay, that can be useful if you wanted to do that. Sometimes we'll do that in a loop because we want whatever that variable is to take on a new value. But also a warning, if you use the same variable name, it will be overwritten, whatever value it had. Okay, last step. Importing functions. So this is the basic syntax. From whatever the new module is, we're going to import a function. This goes back to what in the very beginning of this tutorial, I talked about how the modularity of Python is one of its strengths. So in this case, if we want to get the square root of some number, we have to import the square root function from the math module in Python. Right, that saves us having to develop code to actually compute a square root. Okay, So later we're going to learn how to create our own functions and modules, but for now we're just going to learn how to import functions from Python's math module. A lot of times what happens when you start dealing with a new module is you'll end up at a website like this. So I just followed that link. This is the Python math module, and the math module has lots and lots of functions. Okay. One of them is square root. Okay, and so this shows me the syntax. It's square root parentheses x, and that will give me it will return the square root of x. So to get that into my code, I'm going to have to say from, the module name is math, import the function name, square root. Okay. So then if we wanted to get the square root of 4, for example, we would just do square root parentheses 4. And then here, I'll show an example here. Sometimes we want to get all of the functions that are in a module. So we could just import the module name. So we would just do import math, for example. And I'll show you how that works in a second. The only difference, like why would you not just get all the modules? Well, if you're going to use square root if I did import math, then to use square root, I have to say, okay, in the math module dot square root. Whereas if I do from math import just the square root function, I don't have to tell it to look in math anymore. It just understands square root as it's right. It's brought just that function into my code. Okay, so let's task 9.1 here. I'm going to close the equations file. We'll save this new file as import math. And it says create a program to compute the log of x. Well, log is a function in the math module. And the syntax is log a. So if I, how do I know that? Well, again, you go to the math module and I want to find, I want to know how to do log. There it is. Right, so I can do the log and I can specify the base if I want to. It tells me default behaviors, right? So by default, it's base E. So if I only give it X on log, it's giving me the natural log. Okay. And then there are like other, I can do log 10, in which case it would default to log 10. So in this case, let's just use log and keep it simple so we know it's going to give us the natural log of whatever value we put in there. All right, how do we do that? So from math, right, from that module, import log. You know what? And just for fun, let's from math import square root. And we'll do them both. Okay. So let's say x equals 4. Spaces or not, doesn't make any difference. And now let's print log x, comma, log, whoops, not log, square root, x. And I want them on separate lines. So let's do that separator n thing, right? One thing about coding on the fly, hope I got it all right. And it looks like I did. So I hit the play button, and there it printed the log of 4 and the square root. So natural log of 4 and square root of 4. All good. Okay, and then one last thing here is, let me show you the, if I wanted to use any function out of the math module, I can do import math, right? So that's getting all of the functions from math. If I try to run this, right, I got an error because the functions are not defined if I import the whole module. I have to say math.log and math.square root in order for those to work. So see, now I hit play and they worked. So that's the difference in why you might want to import a specific function versus a whole module. So 9.2 is to generate random numbers between 1 and 100. So now we've got a different module called random, and there's a function called randint that will give us a random integer within those two numbers. So let me comment that, and now we'll do import. Let's do from random import randint. Okay, so from the random module, import this randint function. Let's say x is 4. We want between 1 and 100, so x is 1, and let's say y equals 100. Now we want to print. I'm just going to modify this print statement to be randint x comma y. Okay, and then we'll run it. And so it says 19. Now, because it's a random number generator, if I keep running it, I should get different numbers. Yes. Okay, so hopefully you can see the console every time I hit run, getting a random number between 1 and 100. Now, I specified those as variables, but you know, I could have done this just as easily. Right. So same thing. And the reason I'm showing you that is one of the things as you walk through this that is typical hurdle for people learning to code, and the earlier it sort of clicks, the easier time you'll have, is developing an idea for what the computer sees, right? So the computer sees no difference between whether I put 1 and 100 there, or I had them defined as variables, x and y. Right? That is, so learning to see the variable names as what the computer sees, as values of those variables. It may seem overly simple right now because it's such simple variables holding one number, but when we get to more complex data structures, again, it's just learning to see what the computer sees, or the way the computer is dealing with a variable. Okay, that'll become more clear as we go. That's the end of part 4. Hopefully you've had success. If you haven't, that's what in-person class time and office hours are for. And the discussion boards are always there as well in Canvas. All right. We'll see you again for part 5.